Hi, Tom English again, and the last word problem I want to discuss with you is the age-old problem of money. Classic problem that causes a lot of difficulty in tests, but let's look at a particular problem and see if this helps you with any other money problems. Right now we're saying we have a bunch of coins, and we know the total value of those coins is $13.45. And those coins are made up of nickels and dimes and quarters. And one of the things we've done is counted. We know that we've got twice as many dimes as we do quarters. And we've got 5 more nickels than we do dimes. Now the question is, how many of each of those denominations do we have? Where do we start? Well, what do we know so far? The total of all of them is $13.45. Twice as many dimes as quarters. Well, how can we say that? If we have twice as many dimes as quarters, can we say that the number of dimes is equal to 2 times the number of quarters? Again, you'll notice instead of using X's and Y's and A's and B's, what I'm trying to do is use letters for the unknowns that help you remember what they are. D for dimes, Q for quarters, and of course N for nickels. So if we say the number of dimes is equal to twice as many as the number of quarters, another thing we know from this last one is that we have 5 more nickels than dimes. So how can we express that in an equation? 5 more nickels than dimes. So the number of nickels is equal to the number of dimes plus 5. That make sense? The question though is, how does all that equal $13.45? Well, how much is each coin worth? Okay, we know that nickels are worth 5 cents. So if we say 0.05 times the number of nickels, will that give us the value of the nickels? Sure it will. And to that we're going to add the value of a dime is how much? Well, each one is worth 10 cents. So 10 cents times the number of dimes, that'll give us the total value of the dimes. And finally, the quarters are worth how much? Quarters are 25 cents, so we say 0.25 times the number of quarters. And what's the total value of all three? Obviously, it's equal to $13.45. Okay, but we've got 3 unknowns. We've only got 2 equations. What are we going to do? Well, in this case, we could substitute, instead of the D, we could put 2Q. Then we'd have quarters, but we still got the nickels, and we don't have any relationship between nickels and quarters. But we do have a relationship between dimes of both quarters and nickels. Maybe what we should do is solve for the Q. If we solve for Q, that's equal to what? D over 2. If we substituted D over 2 in for the Q, and we could do the same thing and get N in terms of dimes, then we'd have all one variable, wouldn't we? So let's look at that. Instead of Q, I'm going to change this to D over 2. So I've got 0.25 times D over 2. All I've done is substitute D over 2 in place of the Q, haven't I? And we still have, since we're going to do it all in dimes, we have that value for the dimes. Now what are we going to put in place of the nickels? We're going to put D plus 5. So now we have 0.05 times, in parentheses, D plus 5. Now, again, will those 3 total to $13.45? And what happens when we solve for D? We'll have the number of dimes. Once we have the number of dimes, can we go back into these equations and calculate the numbers for quarters and nickels? Sure. Let's multiply this. 0.05 times D plus 5 times 0.05 is 0.25 plus 0.10 D. Now what do we have here? Uh-oh, gets more complex. Well, we have to divide 2 into 0.25. So that becomes 0.125 times D. And that's still equal to 1345. Can we combine all the D's? We got 0.05, we got 0.10, and we have 0.125. If we add those together, we have 0.275 D, don't we? We've still got this 25 cents by itself, so now we have 0.25 plus 0.275 D is equal to $13.45. 25, subtract that from this side, subtract it from this side. We now have 0.275 D is equal to 13.20. Now a little arithmetic here. We got some division, long division. 0.275 goes into 13.2. And believe me, a lot of kids will throw up their hands at this point. Use your calculator or whatever. I still remember long division. I remember you have to move the decimal point over 3 places to the right. Then we have to move this 3 places. We've only got 2, so we add another 0. And now we have 275. Won't go into 1, it won't go into 13, it won't go into 132. So we're putting it into 1320. This is almost 3. 3 goes into there 4 times. So let's put a 4 up there. 4 times 5 is 20. Carry the 2. 28 and 2 is 30. Carry the 3. 4 times 2 is 8 and 3 is 11. Subtract. I now have 1, 2, I'm sorry. It's 2, 2, 0. Bring down the next 0. Almost 3 goes into there. That's 7 times. 7 times 5 is 35. Carry the 3. 7 times 7 is 49 and 3 is 52. Carry the 5. 7 times 2 is 14 and 5 is 19. Subtract 5, 7, 2, whoops. That's the same amount left over, so instead of 47, it would have been 48, wouldn't it? So what do we find here? We say the number of dimes is 48. Okay? What about the others? Well, we could take this and put it back up into here. If the number of dimes is 48, and we had 5 more nickels, we're going to have how many nickels? 48 plus 5 is 53 nickels. We have dimes of 48, and how many quarters do we have? Well, they're half this number of dimes, 24. How do we know we're right? Put it back in the equation. How much is 53 nickels? 53 times 5, 15, 265. So in nickels we have $2.65. Dimes at 10 cents each. Dimes is equal to what? $4.80. Quarters are worth 25 cents. Again, 25 cents is 1/4 of a dollar. So rather than multiply by 24 or 25, I'm going to divide by 4. So that's an even $6. Let's total. 5, 6 and 4 is, 6 and 8 is 14. Carry 1, 3, 7. 6 is $13.45. Look at that. Where was it? Right up here. We got our answer. Okay? I think that's about as complex as we want to go in these lessons, but hopefully you didn't think it was too complex. It took some calculations, but the main thing is how you set it up, how you substitute, and so you get that final equation into the same unknown. Once you get the first unknown, then the others come. But don't forget to go back and check your problem by multiplying them out, adding them together, and hopefully you'll get the same answer. Thank you.